This question is element appearing more than 25% in a sorted array. So given an array and then the exactly one integer in the array that occurs more than 25%, and then you just return the integer. So it is pretty straightforward. You can just go through the array and then increment the frequency. So increment the frequency, then you can actually know if the integer value is more than what quarter, right? More than, because it has to be more than, so it's at least 25, 26%, right? Something like this, right? So if the value is more than, the value frequency is more than 25%, you return the value. So this is a pretty easy solution. The next solution is going to be you can do this. So this is the first index, right? And then the 25%, which is going to be the quarter of the index. So imagine it's right here. Just imagine. I'm going to compare this one and this one. If these are if these value are the same, right? I know the value between is what are going to be the same, right? Because it's sorted. So I can just return return the integer right away. And then if they are not the same, I would just move. This is just like a sliding window, and then and then keep moving. So this will be the solution, and then the last solution is going to be pretty straightforward as well. So 1/4. This is going to be a first quarter, and a 1/2, and then what? 3/4, right? So I'm going to just do the same and then find out the lower bound for the value, and then comparing, and then if they are the same, I'm going to return it. So let's start with the easy one. So I can just say hash map integer. And then the second integer is going to be represent the count. And then for int num in array, map.put num, map.get or default, num 0 plus 1. So this is basically check the frequency for the value. If you didn't define it in the map, you get it as 0, and then you increment by 1, and then you update the key. And then if map.get num is more than 25%, which is the quarter, right, of the array, then you return num. And if not, you can return return anything. Okay? -1 just in case. Alright, so this is straightforward solution. Time and space is going to be all of n for the space, all of n for the time. And the next one is going to be represent what? The window, right? So j equal to array.length by 4, and then I less than so you will just keep increment, right? And then it will be the array.length minus j, and then I plus plus. So the reason why you do that is because so at some point of time I will become here, and then j will become here, right? So you don't need to let I go all the way to the end. The j will hit the end, right? So if you don't want this kind of solution, you can say j less than but j less than, no, it has to be I, right? Because j is depending on the length of the array, and then it has to be I. So I'm not incrementing j though. So I'm always increment I, and then using this trick, array.I equal to array.I plus j. And if this is true, I return array.I. Also, I return -1. So j is not increment, but you can definitely increase j as well. Let me see. Time and space is a little bit efficient. So time is going to be all of n, space is going to be constant. And the last solution is using a lower bound. So I'm going to say n is going to be array.length, and then in candidate new in array. So it's going to be the first value, array.length, which is n divided by 4. Second one is array.n divided by 2. And third one is array dot n divided by 4 times 3, right? So you can say times 3 divided by 4, like this is the same. So it's represent the quarter index value, half index value, and then third quarter index value. Now I do the full candidates. Traversing based on the candidate only, so only 3 value, right? So I'm gonna get a lower bound, so star equal to lower bound, array, and then candidate. Times if the array at star, so lower bound is definitely less than this index for sure, right? So if star plus n plus quarter, right, equal to array at star, so it's gonna be the same, like candidate, right? And now return candidate. Else I return -1. So how do I get a lower bound? So public. And then in I equal to 0, j less than array dot length -1. So while I less than j, and I will have a k. And if array k, which is greater or equal than a target, which is the right pointer is too large, right? So I will reset to k for j. Else if array ak less than target, now we'll just set I equal to k plus 1, move on to the next index. And you can do else for sure, but I'm doing this just in case. And then lower bound just just return I, right? So yeah, I believe if you swap this value would be a little bit straightforward. The idea is the starting index, the starting value for the lower bound, for lower bounds index, right? This is going to be for lower bounds index, right? And if this is start index. If the lower bound index for the array is equal to the lower bound index plus quarter value are the same, you return you return candidate. So yeah, this is so far so good. So this traverse only 3 3 value, and then traverse lower bound, which is log n for the solution. So time, base is going to be constant. Time, this is constant. This is log n, and then how many times? 3 times. So again, this is log n. So this is better. All right, see you later. Bye.